Welcome back to AERO 3170 Aviation Safety, presentation number 3 on textbook chapter 3 concerning humans as the challenge. So what do you think it takes to be an ideal pilot? What are the factors that define an ideal pilot? And how has that changed since the early days of aviation? So what's the definition of an ideal pilot? Has the definition changed since the early days of aviation? Well, it used to be the definition was someone who was macho. There was a macho image of a pilot with the so-called right stuff. But today, the ideal pilot is defined as someone who can coordinate a highly trained team while managing a complex system. Today, pilots must possess what are called soft skills to safely operate in modern, technically advanced aircraft. So what are some of these soft skills? Soft skills include communication skills, your ability to communicate with your crew members. Leadership skills. As captain, you need skills to lead your crew in an effective manner. And followership skills. As the first officer or cabin crew, you need to have certain skills in order to follow the captain's lead. So again, what percentage of all aviation accidents are attributed to human error, according to researchers? Between 70 and 80% of all aviation accidents can be attributed to human error. So human error is the major cause of aviation accidents today. In the early days of aviation, when aircraft weren't as reliable as they are today, mechanical issues caused the majority of aviation accidents. But today, because of the increased reliability and technology, our aircrafts are much less prone to failure, and so the majority of aviation accidents today are now attributed to human error. Now, one problem that can lead to human error and aviation accidents are distractions. What rule is meant to minimize distractions during critical phases of flight? That rule is known as the sterile cockpit rule. The sterile cockpit rule should be maintained during all critical phases of flight. So what is a critical phase of flight? Taxi is considered a critical phase of flight. Takeoff, approach, and landing are all considered critical phases of flight. Now, the reason that these are considered critical phases of flight is because the workload is quite high during these phases. Before takeoff, during taxi, during takeoff, and then during approach and landing, the work that pilots need to perform during those phases of flight is quite high. The cruise phase of flight is not considered a critical phase of flight. Workload is relatively low compared to the other phases. So what is the sterile cockpit rule? Well, sterile cockpit rule is a ban on any unnecessary communication during the critical phases of flight. So pilots should refrain from discussing anything except for the flight during those critical phases of flight. And this is meant to minimize distractions. Princeton University psychologist George Miller published in 1956 what is now known as Miller's Law. And that law says that humans can only make 7 plus or minus 2 judgments or differentiations. So what does this have to do with aviation safety? What are some examples of Miller's Law? Well, humans can differentiate between 7 sound intensities or 7 shades of color, plus or minus 2. How does this apply to aviation safety? It's been applied to the number of mental objects an average human can hold in their working memory. So accidents are more likely to occur when there is a high workload. For example, during critical phases of flight, when task saturation occurs. This slide depicts what's known as the Yerkes-Dodson curve. The Yerkes-Dodson curve illustrates human performance as it relates to arousal. At the bottom of the curve, you see low arousal up to high arousal, and on the left, you see performance going from weak to strong performance. And at times of low arousal, performance is very low. But as you move into moderate arousal, increasing attention and interest occur. And so performance increases up to a certain point at which optimal performance starts to decrease. And that's because of strong anxiety that is caused by high workload. So this is an illustration of how as workload increases, human performance decreases. In class, we'll discuss what's known as the Goldilocks zone. So what is the Goldilocks zone, and where does this zone fall on the Yerkes-Dodson curve? In thinking about the Goldilocks zone, give some examples of situations where arousal is low, and as a result, performance is low. Situations where arousal is moderate, which results in high performance. And then finally, high arousal situations where workload may be extremely high, resulting in low performance. So as you can see, performance is directly related to workload and stress, but it suffers. Performance suffers at a certain point due to excess workload and stress. And that law is called the Yerkes-Dodson law. The next topic related to human factors that has an effect on safety is called situational awareness. What did the Roman Stoic philosopher Seneca say about human error? He said, "It's human to make mistakes, but it's diabolical to do nothing about it." So what did he mean by this, and what does it have to do with safety? What Seneca meant to say is that humans make mistakes. Humans are subject to error, and there's no way to avoid that. But the worst thing of all is to make a mistake and then do nothing about it. It's important that when we make mistakes, we learn from them, and we try to prevent them from happening again. So what is situational awareness, and why is it so important to aviation safety? Situational awareness is a mental model of your environment. It's your ability to perceive or understand the factors that are affecting you and understand how those factors will affect you in the future, as well as in the present. Dr. Mika Ensley defined 3 levels of situational awareness. The first level she called perceiving critical factors in your environment. The second level is understanding. You need to understand what those factors mean. And then the third level is projecting, being able to take those factors and project them into the future to understand how they will affect you in the future. So the 3 levels of situational awareness, according to Dr. Mika Ensley, are perceiving critical factors in the environment, understanding what those factors mean, and then projecting what that means will happen in the near future. Can you think of some everyday examples of situational awareness? How about driving down a highway at 70 miles per hour, surrounded by traffic? Wouldn't it be important to maintain situational awareness in that situation? running down a busy trail surrounded by walkers and bikers. If you're not aware of what's happening around you, and if you can't project how those will affect you in the future, you could run into some problems. Walking across a busy city street, very important to maintain your situational awareness. Now, in aviation, a critical skill that all pilots must possess is the ability to make decisions. ADM stands for Aeronautical Decision Making, and you'll hear this term quite often. ADM is a systematic approach to help pilots determine the best course of action in any situation. One model that helps pilots with aeronautical decision making is called the DECIDE model, and there are 6 components to the DECIDE model. The first component is detect. So you have to detect that a change has occurred. The second component is to estimate. Estimate the need to react to that change. The third component is to choose. Choose a desirable outcome for the flight. Next is to identify actions that could control the change, and then do the action. Now, this is a circular model. Once you do the action, evaluate it. Evaluate the effect of the action that you took, and then if it's not having the desirable effect, go back to the beginning and detect the change that has occurred. Another human factor that has led to several high-profile accidents is fatigue. What federal aviation regulation was written to address fatigue in commercial aviation? Well, FAR Part 117 is the federal aviation regulation that addresses fatigue in commercial aviation. And starting in 1993, the NTSB began to include fatigue as a probable cause for some accidents. FAR Part 117 includes some important definitions. The definition of an augmented crew in FAR Part 117 is a crew that requires more than 2 pilots. More than 2 pilots are usually required due to the length of a flight. So most international flights require an augmented crew. The next definition concerns different rest stations. A Class 1 rest station is defined as a bunk or other surface that allows for flat sleeping position and is located separate from the flight deck and separate from the passenger cabin, where the temperature is controlled and it allows the flight crew member to control light and provides isolation from noise. So this is the best class rest station. A Class 2 rest station is defined as a seat in an aircraft that allows for a flat or a near flat sleeping position that is separated from passengers by a minimum of a curtain, and it provides some darkness as well as some sound mitigation, and is free from disturbance by passengers or flight crew members. So this is the second best type of rest station. And then finally, a Class 3 rest station is defined as simply a seat in an aircraft, cabin, or flight deck that reclines to at least 40 degrees and provides leg and foot support. But that's it. So this is the least desirable rest station. FAR 117 defines 3 different types of fatigue. The first one is called transient, and that's brought on by sleep deprivation. Cumulative fatigue is repeated sleep deprivation. And then circadian fatigue is reduced performance between the hours of 2 a.m. and 6 a.m. One of the things that the Federal Aviation Regulation Part 117 requires of all passenger airlines, Part 121 passenger airlines, is called an FRMP. What does FRMP stand for, and what does it mean? FRMP stands for Fatigue Risk Management Program, and airlines must establish a fatigue risk management program to manage the effects of fatigue on crew members according to Part 117. The accident that led to the passage of Part 117 was UPS Flight 1354. Both crew members were killed in this accident when the aircraft landed short of the runway. So what did the NTSB say about the first officer's use of crew rest time? Apparently, the first officer didn't use crew rest time appropriately. How did they know that the first officer didn't use her crew rest time appropriately? The NTSB looked at the first officer's cell phone records before the flight. Those cell phone records indicated that the first officer was not using her rest time to get adequate sleep. As a result of these findings, the NTSB recommended that Part 121 airlines should implement a fatigue risk management program. And that was actually passed for Part 121 passenger airlines. Ironically, the cargo industry got an exception, and so only Part 121 passenger airlines are subject to Part 117. Part 121 cargo operations, like UPS and FedEx, are not subject to Part 117. Another human factor that affects modern flight crews is called automation surprise. What is automation surprise? It's when technology doesn't work as expected. So an example may be when a pilot sets the autopilot to follow a course, and for some reason the autopilot does not follow the expected course. Sometimes when the response is expected, the actual response goes unnoticed. Another factor that can lead to confusion is called mode confusion. What is mode confusion? It occurs when you select a certain mode for automation and it results in a different mode that results in confusion. And the common question you'll hear is, what is it doing? An example may be setting your autopilot to climb, but instead the airplane begins to descend. A common problem with humans and automation is something called GIGO. What does GIGO mean? GIGO stands for garbage in, garbage out. Computers will process senseless data that you input into the computer and produce an output which is usually undesired. While computers are extremely capable and can perform tasks very rapidly, they aren't smart. Computers will only do what you tell them to do. And if you tell them to do something stupid, they will do something stupid. A good example that illustrates the problems that can occur between humans and automation is Asiana Flight 214. So what happened to Asiana Flight 214? Was the problem automation surprise, mode confusion, or garbage in, garbage out? And finally, what was the result? Asiana Flight 214 crashed short of the runway in San Francisco. It's a Boeing 777, and the first officer mistakenly believed that the auto throttle mode was selected. Auto throttle is supposed to control the aircraft's speed. When the pilot noticed that the speed was getting dangerously slow, he realized that he was confused about the auto throttle, and he tried to take control of the aircraft manually, but it was too late. One tool that has been developed to understand how human factors can lead to aviation accidents is called HFACS. What does HFACS stand for? HFAC stands for Human Factors Analysis and Classification System. So what is HFACS, or Human Factors Analysis and Classification System? It's a tool for investigating, analyzing, and classifying human error associated with aviation accidents and incidents. HFACS also uses the 4 barriers in Reason's Swiss cheese model. What are those barriers? Remember, the first one is organizational influences. The second one is unsafe supervision. The third one is preconditions for the unsafe acts. And the fourth is the unsafe act itself. Organizational influences include resource management, organizational climate, and organizational processes. Unsafe supervision includes inadequate supervision, planned inappropriate operations, failure to correct a problem, and supervisory violations. Preconditions for unsafe acts include environmental factors like physical environment, condition of operators, for example, mental limitations, and personnel factors, including crew resource management and personnel readiness. And finally, unsafe acts include errors and violations. This is the end of Chapter 3, Humans as the Challenge. The next presentation will be on Humans as a Solution from Chapter 4.